plus 100. And second problem, a little bit, it contains a number of poles and zeros, but anyway, it's easy because we came across many problems based on asymptotic board plot. So we'll see one by one. So first problem, um, transfer function, okay, so g of s equal to, what is that, 1 divided by 2s plus 100. Okay, so convert this into board form. So board form of the transfer function, and g of s equal to 1 divided by, you take 100 outside, then it will be 1 plus 2s divided by 100. Okay, then this is equal to 100 into 1 plus s divided by 50. Okay, so this is your board form of the given system, and it contains two terms. Okay, 1 by 100 into 1 divided by 1 plus s divided by 50. Okay, so this is constant. Okay, and this is simple board. Simple board. Okay, so you should remember, that reference page. Okay, so I have circulated some reference page for you to start the, what is that, asymptotic board plot, and those references are available in the, what is that, and module 5 folder. That Google Drive link I circulated on during the yesterday class. Okay, so make a copy of that particular sheet, and before starting, some problems in the asymptotic board plot. Okay, so you should thorough about the basic board plot of constant, simple pole, and simple zero, and that second order system assumptions. Okay, then only you can able to draw the board plot of this particular function. Right, we can see one by one, and here this is a constant, so convert this constant value into dB. Okay, so 20 log 1 divided by 100 equal to 20 log 1 minus log 100. Okay, so as per logarithmic rule, and this will be 0, and this can be written as minus 20 into what is that, 2. Okay, so this is equal to minus 40 dB. Okay, so the equivalent value of 1 by 100 in dB equal to minus 40 dB. Okay, so all this, asymptotic board plot and as well as actual board plot, it should be drawn by using a seminar sheet. So remember this point, it is most important. Okay, so this is x-axis, log omega scale, and this is gain in dB. Okay, so gain in dB, and this is 0 dB at the origin or 0 dB at the axis, and here it is 20, 40, and 60, and minus 20, minus 40, minus 60. Okay, here I am doing, 0.1, 1, 10, 100, okay, and 10 power 3. Okay, so every dB is multiplied by 10. That's the reason the slope is called as dB per dk. If every frequency is multiplied by 10, then the slope is called as, or can be represented as dB per dk. Okay, right. So remember this point. And first step, you can see, we are going to plot, what is that, 1 by 100. Okay, 1 by 100 in your magnitude plot. So this is magnitude plot, a magnitude plot drawn between gain in dB versus omega. Okay, gain in dB versus omega. Okay, so what is that? What is the gain equivalent for 1 by 100? It is minus 40. So minus 40 dB. Simply we can call it as, I can choose different color. Pointer options and ink color. Okay, so use scale and draw this. Okay, this is minus 20 log 100. Okay, minus 20 log 100, and the slope in a straight line. So it will be 0 dB per dk. 0 dB per dk. Okay, and this is your magnitude plot of your first element. First element is nothing but what is that? 1 by 100. And second element 1 by 1 plus s divided by 50. Okay, so 50 in the sense, and it is a simple pole. Am I right? It's a simple pole and added with 1, so automatically I can choose different color to represent this. Find an option. Okay, right. So here, where is 50? This is 10, and 20, 30, 40, and 50 here. This is 50. Okay, right. Another corner frequency 50 can be multiplied by 10, then it will be 500, 200, 300, 400, and 500. This is another corner frequency, and 500 multiplied by 10, it will be 5000. So this is 1000, 2000, 3000, 4000, and 5000. Okay, is it clear? So try a reference line here, and here also reference line, also reference line. Okay, so magnitude plot of 1 divided by should be like this, and so I can able to draw like this. Okay, so this is magnitude plot of is that second element. Am I right? So dB per decade, I can say it's minus 20 dB per decade, minus 20 dB per decade. Am I right? So this is your magnitude plot of your second function. Now we have to combine these two things. Okay, so for that, this is up to, this is 0 dB per decade, and I can able to say portion A up to this. This is portion A, and okay, then after that this will be portion B. Okay, portion B. So up to portion A, this is also 0 dB per decade, and at portion A, okay, so if you are adding the slope, then it will be 0 plus 0 equal to 0 dB per decade. Am I right? Now up to this portion, okay, it will be followed. Okay, I can say up to okay this portion. Okay, then after that you can see it is simply it is following what is that? Sorry. So, it should be like this. Okay, then after this, okay, it will simply another 20 dB, so it will be like this. Okay, so this will be like this, because here the dB is the dB is 0 dB per decade, and here it is minus 20 dB per decade. Okay, right. If these two are added, then at each magnitude of here minus 20 dB will be added, so the curve will be shifted like this. So this is minus 20 dB per decade. If you want to draw the magnitude plot, okay, this will be your, what is that, bode magnitude plot. Bode magnitude plot. Is it clear? Okay, so it's very simple problem, and we can able to understand because it contains only two terms. Okay, then we will try to draw the, what is that, phase plot. So phase plot, it can be drawn between, what is that, log omega and phase angle in degree. Okay, it's 0 degree, and here it is 90 180, 270, and here minus 90, minus 180, minus 270 degree. And here it is 0.11, 10, 100, 10 power 3. Okay, is it right? Now, while drawing the phase plot, we have to take care of the two terms. It's a constant. Okay, so when we are projecting a constant into phase plot, it is nothing but it's origin. Origin. Okay, so here this is term one, projection to phase plot. Okay, the next term is 1 divided by 1 divided by 1 plus s divided by 50. Am I right? So if you're talking about 50, first term 1 divided by 50 divided by 10, it is 5, and 50 into 10 equal to 500. So you mark these 2 points first. So 5, where is 5? This is 1, 2, 3, 4, 5. Okay, this is your 5, and 500, this is 100, 200, 300, 400, and 500. So this is your next part. Am I right? So while drawing that phase plot for a simple pole, and you have to consider this, you please extend a line and be more convenient to you. Hmm? Okay, perfect. Now, what will happen? This first plot line, 1 minute, I will change the color. Okay, so here, this will be your magnitude plot. Here it will break down and slope changes. It will reach the, what is that? 90 degree, 90 degree at 500, and it will go like this. Am I right? So here dB per decade, it's there are here it is minus 45, minus 45 degree per decade. Am I right? So next corner frequency, it's at 20, 30, 40, 50. We're measuring this angle. Okay, it will be approximately 45 degree. So from here to here, it is 45 degree. So automatically what will happen? The slope in degree, it is nothing but minus 45 degree per decade. If you're combining the two plot, okay, 1 and 2, we will get a first plot like this. Okay, so the first plot will be like this. Okay, and the exact, I mean uh, okay, this will be your uh, first plot. Okay, so first plot of the uh, G of S. Okay, so this is the way to draw the, what is that, the first plot of the given system. So I hope you can able to understand, because we solved many problems in this. We'll move to next problem. 1 minute, I will create another page. 1 minute. So there is a loading problem. Sufficient. Okay. We will move to next problem. Okay. So what is our next problem? Find the Bode log magnitude plot for the given transfer function. So the transfer function equal to 200 into s plus 20 divided by s into 2s plus 1 into s plus 40. Okay, so this is your next transfer function, and most probably you may get a problem with more number of poles and zeros. Okay, so you do more practice in this. So this is your second problem of this particular class. So TF transfer function equal to 200 into s plus 20 divided by s into 2s plus 1 into s plus 40. Okay, so this is your transfer function. I can say g of s equal to 200 into s plus 20 divided by s into 2s plus 1 into s plus 40. Okay, right. Now we have to convert this into board form. Okay, so board form g of s equal to 200 into, you take 20 outside, then it be 1 plus s divided by 20 divided by s into 1 plus 2s 40 into 1 plus s by 40. Okay, right. So now you can say, you can cancel. Okay, so this is 5 times, and automatically, uh, any other, nothing. Okay, so it will be 100, am I right? So 100 into 1 plus s by 20 divided by s into 1 plus 2s 1 plus s by 40. Okay. So this can be written as g of s equal to 100 into 1 plus s by 20 divided by s into 1 plus 2s into instead of 2s. Okay, you can write it as s by 1 by 2, s by 1 by 2, and 1 plus s by 40. Okay, and this is equal to 100 into 1 plus s by 20 divided by s into 1 plus uh, s divided by 0.5. Okay, 1 plus s divided by 40. Okay, right. So this is your final board form. Okay, so board form is nothing but you have to convert the system transfer function into 1 plus s format. 1 plus s format. So we finally we converted all the things into 1 plus s format. Then g of s equal to, first is 100. Now we are going to separate the terms. 100 into 1 plus s by 20, 1 plus s by 20 into 1 by s into 1 by 1 plus s divided by 0.5. 1 by 1 plus s divided by 0.5. Okay, into 1 plus s divided by 1 divided by 1 plus s divided by 40. Is that clear? So totally how many terms we are getting? This is first term, and this is second term, this is third term, okay, and this is a fourth term, and this is a fifth term. Okay, so totally we are getting 5 terms. So this is a constant, and this is simple 0, and this is integrator. Okay, and this is simple pole because it is appearing at the denominator, and this is another simple pole. Okay, so there are 2 pole, 1 integrator, 1 simple 0, and a constant. So before getting to magnitude plot, you should know how to draw this function individually. Okay, so you have to mug up those basic rules. I have circulated some one page, shortcut table for you. You please take a printout of that, and you please mug up those concepts, because if you want to draw the asymptotic bode plot for the given transfer function, you should remember. Okay, then only you can able to draw. If you are remembering the bode plot of individual terms, then it's very easy to solve this particular problem. Okay, and this particular problem is very much useful in case of competitive examination. In all type of electrical based competitive examination, definitely they will ask problem from the board plot, or a board plot, how it can be used in the frequency domain analysis. So you do more practice, and I have given a lot of references in my drive, so you work out all those problems. Okay, and as well as you can get number of problems from the gate questions also. So you can search in the Google search. There you write it as gate questions based upon board plot. Okay, so you will get the collective question bank with respect to the what is that, the board plot. Okay, so they may collected all the gate question papers, and based upon the topic called what is that, the board plot. Okay, so you do the practice whenever you are free, and it will be much helpful for your competitive examination. I hope you can understand. Now we can start. What is that? The board magnitude plot. Okay. All right. Here, before get into the board magnitude plot, and this is uh, constant, and convert this into dB. So for that, take 20 log of 100 equal to 20 log of 10 squared, and here this is log based. So as per logarithmic rule, okay, so 20 into 2 is 40 dB, right? So it's a 40 dB positive dB again. I hope you can able to understand it. So usually you take some semi-log sheet. There I can see. So normally in your university examination, they will provide only one semi-log sheet. So within one semi-log sheet, you have to complete both the diagrams. Okay. So you carefully do your scaling while drawing the magnitude and as well as phase plot, because they will not provide additional semi-log sheet. Maybe available, and it depends upon the number of problems. They will circulate the board plot, I mean semi-log sheet. So normally they will provide only one semi-log sheet. If necessary, they will provide second semi-log sheet. But in case of the board plot, and both the diagram, I mean both magnitude and as well as phase diagram can be drawn by using a single semi-log sheet. Okay. So here, for your understanding, okay, I'm taking two different graphs. Okay, so first one, uh, magnitude plot, log omega scale, and this is gain in dB, and here it is 0 dB, and this is 20, 40, 60, and this is 80, minus 20, minus 40, minus 60, minus 80. Okay, then upper frequency is 0.1, 1, sorry, 10, 100, and 1000. Okay, right. Now you have to draw the, what is that? The first value is plus 40 dB. Am I right? So while converting the constant into what is that? The magnitude plot. The first plot is okay, 40, 47 straight line. Okay, so this is your first plot, and it is 0 dB per TK. 0 dB per TK. Am I right? Then second plot, it is second function is simple 0. It's a simple 0, and whose frequency is 20, and it is 1 plus 1 plus s divided by 20. Okay, where is 20 here? It is 10, and it is 20. Okay, so the simple 0, I'm changing the color. I can say up to 20. Okay, 20. Next is 200, and next is 2000. Okay, this is most important. Okay, so we mark this point, and okay, so it should cross here. Okay, then okay, so it will go like this. So this is magnitude plot of a second term, and it will be 20 plus 20 dB per decade, plus 20 dB per decade. The next is, third term, it is the integrator, and it's called a simple pole at origin. So S divided by 1. So it can be written as S divided by 1, and this is your corner frequency. Where is 1? And 1 is here. Okay, and it will be like this. Okay, this will be like this. So this is your third term. This is your third term. Am I right? Right. Next is, this is also, minus 20 dB per decade, minus 20 dB per decade. So why it is minus 20? From one frequency to another frequency, how long it is crossing? It is minus 20. That's the reason minus 20 dB per decade. Okay. If you are multiplying this 1 with 10, the next corner frequency will be 10. Am I right? So that's the reason it is minus 20 dB per decade. And fourth term, 1 plus s divided by 0.5. 0.5 is your corner frequency. Where is 0.5? This is 0.1, 0.2, 0.3, 0.4, 0.5. The next corner frequency, it is 5. 2, 3, 4, 5. Okay. The next corner frequency, 20, 30, 40, 50. The next is, 500, 200, 300, 400, 500. So you mark this clearly so that we can able to easily draw the magnitude plot. It's most important. 2003 is 5000. Okay, right. Now, this is your fourth plot. I will change the color. Color, I will take green. Okay. So what will happen? And here it will cross here, and it will cross here, and it will where is that 60? It will cross here. Am I right? So it will be from here 1 plus. Okay. Okay. So it will be going like this, and here also it is minus 20 dB per decade. Am I right? So this is your fourth term. This is your fourth term. Okay, am I right? So we completed fourth term. Then fifth term, 1 divided by 1 plus s by 40. 40 is your corner frequency. Where is 40? 20, 10, 20, 30, 40 here. Okay, this is 40, and 400, 100, 200, 300, 400 here, and 4000, 2000, 3000, 4000 here. Am I right? So this should be extended. This should be extended like this, and this will be extended like this. So I can say it is 1 plus. Okay, and it is crossing here, and it will be crossing here. Okay, and this is also minus 20 dB per decade, and this is your fifth term. Am I right? So now, we have drawn magnitude plot for all the function, all the 5 functions. Now we have to combine this. We have to combine what is that? All the plots. So I can say pointer options in color. Okay, I can choose a different color. So this is your first portion, and I can say Okay, this is portion A up to this A. Okay, and then up to this B. Okay, then up to this C. Okay, then up to this C, and here it is D. Okay, so there are a number of portions are available. If you are checking here, um, okay, so up to A portion, you can see this is 0 dB per decade, 0 dB per decade, and this is minus 20 dB per decade. So at position A, okay, I can say 0 plus 0 minus 20. So it will be minus 20. Am I right? So up to this, okay, so it will be minus 20. So I can able to draw like this. I can able to draw like this. Am I right? So then after this, I can say it is minus 20 and up to B. Okay, so B, I can say this is 0 plus minus 20 and minus 20. So it can be drawn this. It can be drawn like this. Am I right? So then after from B to C, I can say from B to C, once again this is 20, okay, 0 plus minus 20 and minus 20 minus 40. Am I right? So minus 40 in the sense, and this is 20, 20, okay, and minus 40 it will come, then automatically I can say from here to 20, 40 dB should be there. So here it's 0 to 20, each carries 4. Each division can carry 4 dB. So from here 4, 8, 12, 16, 20. Okay, so 16 or 20. See, during the next 40, it will be 4, 8, 12. So it will be like up to what is that? See, it will be like this. And this is minus 40 dB per decade. Okay, and this is also minus 40 dB per decade. Then from C to D, okay, C to D, I mean at D, I can say from C to D, it is plus 20 and plus 0, minus 20, minus 20, I can say. So from here to here, I mean up to the portion D, up to here. Okay, so this is minus 20 dB per decade. Then after this, you can see minus 20, minus 40, minus 60. Once again, minus 40. Approximately, this will be minus 40 dB per decade. Okay, so this is your magnitude plot. You can draw roughly. Okay, this will be your uh, magnitude plot. This will be your magnitude plot of the given system. Okay, so I hope you can understand, and this is the asymptotic magnitude plot of the given system. Okay, right. Now we are trying to draw the what is that phase plot. Similarly, it can be drawn. See a phase plot. So while going towards the phase plot, and we have to exactly calculate the what is that the phase values of the given function. So I'm going to copy this. 1 minute. Say now. Right. So here, this is another calculation. Okay, you forgot about this. Forgot about this. here I'm going to do, that phase plot calculation. So regarding, second term, first term is a constant. Okay, so we don't need to bother about, you know, the first plot calculation of the first term, and it will be, it's a simple constant. Okay, so when we are talking about a simple constant, and it is, it will get the minus 90-degree value. Okay, right. So second term, it will be 1 plus s divided by 20, and here you have to divide the frequency. So 20 divided by 10, it will be 2, and 20 into 10, it will be 200. So this is your assumption. Third term, it is an integrator. Okay, so if you are talking about your integrator, and this will be, your minus 90-degree, and constant, it will be a point. It will be a point, or a 0-degree angle, and here if it is an integrator, it is a minus 90-degree. Okay, so second term, it's minus 90-degree, and third term, phase angle. Phase angle plot. Okay, this is a calculation for phase angle plot. A third term, it is corner frequency is 0.5, 0.5 divided by 10, it will be 0.05, and the 0.5 into 10, and it is equal to 5. So this is the minimum, and this is the maximum. Then fourth term, and the corner frequency is 40. 40 divided by 10 equal to 4, and 40 into 10 equal to 400. Okay, so with this assumption, we have to draw the first plot of the given system. Okay, all right. For that, draw the first plot values, and this is log omega, and this phase angle in degree, and this is also phase angle in degree. This is 0-degree, 90, 180, 270, and 360. So minus 90, minus 180, minus 270, minus 360. Okay, and here it is 0.1, 1, 10, 100, or 10 power 3. Okay, so what is the first plot? First plot is 100, and a constant is projected into a phase angle plot as a point. Okay, so this is your first plot, and second is, 1 minute, sorry. Second is, integrator, and integrator is minus 90-degree. Okay, so this is your second plot. I mean, third plot. Okay, so this is your third plot, and second one, it is, 20. Okay, so 20. So minimum is 20, and maximum is, 200. Okay, so minimum is 2. Where is 2? 1, 2 here. Okay, this is 2, and maximum is 200 here. So it should cross here. So it will be this. Okay, so this is your what's that? Second plot. Okay, so this is your second plot, and third plot, 1 by s, and it is already been drawn. Then fourth one, 0.5, 0.05 to 5. Okay, 0.5, 0.05. This is 1.01 here. 0.01 means 1, 2, 3, 4, 5. 0, 1, and 5. 5 means 1, 2, 3, 4, 5. 2, 3, 4, 5. Here. Okay, so extend this line, and extend this line. It should cross. Okay, so it cross 90-degree, and it will be like this. Am I right? So this is your fourth point. Then next is, fifth one. It is 40, 44, 400. Okay, where is 4? This is 4. Am I right? So it will be like this. It will be like this. So this will be your fifth term. So this is your, approximation, And here you have to do the, what is that, all the calculations up to this A and B, C, D, okay, then it will be E, okay, so, and this is F. So up to A, it will be 90 degree, okay, so it will be 90 degree. 1 minute. Interaction in color, can say up to A it is a 90 degree, 90 degree. Then after A to B, okay, up to A to B is 45 degree minus 45 degree per decade, 45 degree per decade. Am I right? So up to B, this will be here degree per decade. Okay, this is minus 45 per decade. Then from B to C, it is 45, it is 45, and it will be 90 degree. Okay, it will be 90 degree. So it means that 180 plus 90 minus 90 degree per decade from C to D. Okay, 0, once again, 90 degree minus 90 per decade from D to E, it will be 45. So this is minus 45 here, and I can say this will be drawn like this. So this is your first plot. This is your first plot of the amplifying system. So we can able to draw the, what is that, asymptotic magnitude and the first plot like this. I hope you can able to understand this. Okay, so I'm going to stop here itself. Then the next class onwards, we are going to start, what is that, exact board plot by using the different procedure. Okay, is there any doubt? Yes, is there any doubt here? Yeah, I can take the attendance.
Sir, roll number 5%.
Oh yeah, all of you tell your attendance now.
Sir, 5.
1 minute, I will say one by one. What about roll number 5%? Then roll number 9. Okay, roll number 12.
Sir, 12%.
9%.
Sir, 12%.
12%. Okay.
Sir, roll number 7%.
17. Okay.
Sir, roll
Okay,
number
thank you.
7%.
Okay, noted. I noted.
Sir, roll number 2.
Yeah, I noted.
Sir, roll number 17%.
17. Okay. Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
And all of you keep
you,
at least
sir.
5 graph sheet for your series 2 examination. Okay. So this is instruction from my side. You keep at least 5